Hey, hello guys. I needed to make a video about the AX-14 Golosa, and I need to tell you some stuff about it. So if you want to use the 6 pairs, these are some things that you need to know before you continue. Right now, you need to change, since this one will have 6 pairs. You can feed this amplifier with maximum voltage of it can be from 50 volt all the way up to 85 volts, depending on what you have available at home. So depending on what transformer you have, but keep in mind that you need at least a 650 VA toroidal transformer, or probably more, even more, maybe 800 VA, probably a 1K, maybe 1K. You can use 1K too on this design because it will have 6 pairs. So right now, make sure that you will have a 15 amp fuses on the rails, so to make sure that it will fit enough current to the rails of this design. One other thing that I need to tell you is that you need to change R19 and R18 to, depending on what resistor you have available. Not everybody have parts available with the correct value. It can be from 470 ohms to all the way up to 560 ohms. As you can see, I already changed those. The reason I changed those resistors, so this area of the circuit is not going to be stressed with too much current or voltage. The voltage is going to be higher, so that's to avoid the stress on this circuit. You can see I highlight all the IPS circuit area of the amplifier. Also, if you are going to feed this amplifier with 1 volt peak, depending on, you have a preamplifier. Right now I have 1 volt peak, 1 kilohertz. So you need to change R11 to 16K, so the amplifier is not going to be that sensitive. So right now also you need to change R2 to 16K. So make sure you have those values changed if you are to use 6 pairs on this design. Right now this amplifier can deliver up to 595 watts, or close to 600 watt, probably 600 watt, depending on your, of course, depending on how big is your transformer. If you have a small transformer with a lower VA, volt amps, voltiampere, that's the way I say it in Spanish, so you're not going to be able to deliver that amount of power. So that will depend on how big is your transformer. Keep in mind that depending on your transformer is the output that you're going to have. So do not pretend to have a 300 VA, or probably for let's say 300 to 220 VA transformer, toroidal transformer. Is not going to deliver enough power. So make sure your toroidal transformer is a really large one, probably 1K VA. It should be fine for 2 channels on this design, so you can deliver a lot of power. So right now on the results of the simulation, I have from 1 volt peak, a sine wave of 1 kilohertz. I have 595 watts. I mean that's plenty of power. Right now I have a 4 ohms low. So make sure you have a good transformer. The only thing you gotta do is just make those small changes. Like I say, R19 to 500. It can be 470 ohms, or can be a 500 ohms or 560 ohms, just to avoid stress this area of the IPS circuit. And do not forget to change the R11 to 16K. That's the negative feedback resistor. This resistor is really important. Do not forget that. And R2 to 16K. One more thing that I got to tell you: the bias adjustment. You can adjust the bias to about 15 millivolts. So depending on your area, if you have a really hot weather, just try to keep the bias maybe a little bit lower, just in case, so the transistor do not suffer from heat. And the heat is the thing that destroys the transistor. When the transistor they get really hot, they blow up. So you gotta make sure that after you complete the PCB, you will use a light bulb, of course, a 100-watt light bulb, to make sure that after you turn on the circuit, is nothing. The light bulb will stay like a dim, not that bright. That means that the circuit is okay. But if you see that the light bulb turn on really bright, that means that there's a short, what the hell is that? A short circuit or something, or probably a mistake from the circuit. Right now, I'm going to show you right now how to adjust the bias. Make sure that there should not be any speaker connected to the circuit. Right now, I disconnect the circuit. Also here, you can actually, I'm making the video in English because I know that some people from other countries or places, they do not understand Spanish, so that's why today I'm making the video in English for you guys, so you can understand better, because I know that I post stuff in Spanish because I got a lot of friends from different part of the Latino America. So Latin America Latino America, did I say that right? Anyway, so you can short out the input. You can actually short out the input for the, and then you will remember after you use the light bulb to test the amplifier, then you will proceed to continue. You need to remove the light bulb so to continue and make the bias adjustment. So right now I'm going to place a multimeter to read one of the bias resistor. Okay, there you go. We're going to place it in parallel to this emitter resistor from this power transistor, and now I'm going to check the bias adjustment. Let me see the last time okay, I think that's too high, 24. Okay, I was reading a book, one amplifier designer, J. Randy Sloan, he's a writer of that book. He recommended to adjust the bias to about a, let me wait for the pickup, the truck to pass by. It's making too much noise. Hold on, give me a second, guys. All right, thank you, Mr. Truck. You're making a lot of noise. So right now, he recommended for Class A/B operation on this design to have a lower crossover distortion. He recommended 47 millivolts, but this is one way I do it. Reading one particular emitter resistor, but actually you can measure it this way too. Let me okay, I think I activated. Gotta delete this. You will read. Let me. I gotta move this. All right, there you go. So as you can see, this is another way. As you can see, I'm measuring the emitter on this resistor right here. As you can see, it's connected to this emitter, and the other side, as you can see. And now I'm going to read a different value. Let me see. I got 49.4. I think it's too high. It's supposed to be about 46.5, maybe 40. No, it does not need to be perfect, but close to those values, at least to get the 47 millivolts. So right now I need to adjust this, but that's a little bit too high, so I need to adjust it. I think it's too high, so probably I moved it by mistake the last time I was checking the files. Okay, that's 50 millivolts. That's too high. It's supposed to be about 47 millivolts. Okay, let's go lower. 47 millivolts. Okay, we got 47 millivolts. That will depend on if you have a good heat sink. If you have a really large heat sink, that means that you can do this adjustment, so you don't have to worry about the thermal runaway. It's just that they call it the thermal runaway. That means that if the heat is way too hot, I don't know if you guys saw my video. I was explaining something about my honey badger clone. One day I was testing my honey badger, but that day was so hot. It was a really hot day. It was like 85 degrees, something like that. 85 Fahrenheit. Sorry about that. It's not centigrade, Fahrenheit. So it was so hot. I was after I adjust the bias, I was listening to music for about maybe 30 minutes, but I did not realize that the heat sink that I have, it was not enough for the circuit. So after a few more minutes listen to music, all the power transistors, they blow up. They blow up because they cannot withstand that much heat. Because I do not have a really a proper heatsink. So if you have a good heatsink, you can adjust it to this bias adjustment. But if you have a small heatsink, you can do this. You can adjust the bias to a lower value. One example, you can adjust it to about 15 millivolts. One example, I'm going to use it, the old method, old way to do it, just reading the voltage drop of this resistor. So right now I'm going to adjust it to a lower value on one single, let's say 115 instead of 23.5. We're going to adjust it to 15 millivolts. So in order to keep the power transistor not working so hard, so to save them. So depending on your weather condition where you live, maybe where you live is really hot, so this is a good idea to keep those power transistor operating on lower how you say temperature, because they're gonna be hot. So right now I'm going to change this to about 15 millivolts. I gotta adjust the bias to a lower right now we have 15.7. Let's adjust this to about 15 millivolts. There you go. We're getting closer. Okay, 14.9 is fine. I mean, it does not need to be perfect. If you have 14.9, it's okay, because it's gonna compensate with the this biased transistor Q10 is going to be attached to the heatsink. So this one is really important. I'm going to show you the illustration. So give me a second, guys, so I can show you. Okay, this is not the one. Okay, it's okay. This is a little illustration is fine, but at least I want to show you the file. Okay, that's not what it is. All right, I need the 6 pair of version. What is it? No, that's a 4 pair. I have all versions. I have the sorry about I'm talking about all this stuff. I got a 4 pair version. I got 3 pair version. Let me see. I got the 2 pair version, and what else? I think that I have. Okay, this is 3 pair version. This is the 6 pair version. So this is the largest one. So wow, I forgot what. Okay, I forgot what I was about to say. Okay, this one. This transistor is a really important transistor. This is the bias transistor. Is a really important transistor on the circuit. That's why I left this path. As you can see, there's a emitter, collector, base, so you can actually use a wire to attach the transistor, and you can place it anywhere you want on the heatsink to make sure that it will track the temperature of the heatsink. Depending on the temperature of the heatsink, it will change the bias a bit, you know. So depending on the temperature, it will adjust the bias depending on the temperature. That's why I left this path here. If you want to attach by wire this transistor. Okay, I recommend not to use this one here. This one will work fine, but you can use a different one. You can use the MJE 340Gs to be sure, because this will withstand more current, more voltage. I think it's more voltage. Sorry about that. It's more voltage. So also, but anyway, also you can use this one here, but the other one is more strong. I think it's more can withstand more voltage. I think yeah, that's the correct way to say. All right, right now this resistor is a really important resistor. This is the negative feedback resistor. If you are to use the 6 pair, like I said before, you can change this to 16K. One sample I'm going to do it right now, so you can visually you can see what I mean. So now this one is 16K. This capacitor you can change from 10. Okay, it can be 3.3 picofarad up to 47 picofarad, depending on what capacitor you have available. But this capacitor might change the tune of the amplifier. So you gotta experiment with this capacitor. Right now I have 47 picofarad. I have this capacitor on my PCB. I think it sounds pretty good. I mean, I'm not an expert, but I think it sounds pretty good. I have 47 picofarad. Okay, what else I need to change to show you? Right now, this these resistors are the one that I was telling you that you need to change. I forgot to do it here, but you need to change this depending on what, you know, not everybody have parts available right away. So it can be from 470 ohms. This can be 1 watt or 2 watt resistor. Does not matter. Okay, one sample. Let's say this one can be 2 watts. It's okay, 2 watts. A 2 watt resistor now is 470. Can be 470 ohms or 500 ohms. It's okay. So I'm going to change the other one. These are the ones that feed the circuit, the IPS circuit of the amplifier. So let's change this to 470 ohms. 2 watts. 2 watts is fine. Can be 1 watt, 2 watt, a half watt. But I would recommend it to have a little larger value. 1 watt is fine. And these two transistors, you can actually place a heatsink if you want to. They do not need a heatsink because on my circuit does not have the heatsink. But I think actually you can use a heatsink here. It does not matter. All right, we have here the diffuses. I gotta change this value because actually you have 6 pairs. You can feed this amplifier with a maximum voltage of 85 volts DC. So from 50 volts up to 85 volts DC. That's why you need to change this resistor. These are the ones that will feed the circuit. One sample I'm going to show you. Okay, this is the positive area of the amplifier. As you can see right here, these are the driver transistor. Sorry about that. The driver transistor Q13 is really important, and this one here Q11. Those are the drivers to feed the. I mean, to. That's another way to say. I forgot to. Well, okay, let me see. Let me think about it. Because these will feed this resistor. Oh, this one here. Sorry about that, but you need to change this one here to 180. 220 is okay, but it needs to be 180. 180 is fine. 180 ohms. If you have 220, it's fine. I mean, try it with 220. I don't think it's a big deal. I already tested with 180 and 220, and it works fine. Okay, right now I have 180. Let me see. Let me check. I'm going to change this to 220 just to be sure. 220. All right, 220. Okay, I forgot to change the. Okay, I already adjust the bias. So right now, oh yeah, I gotta adjust the bias one more time because I changed that value. I think. Let me see. Give me a second, guys. Okay, you can see after I change the R20, this one here, R20, the value of the bias it moved a little bit. So I need to adjust the bias one more time. I'm going to do it right now. I need to have 15 millivolts. All right, give me a second, guys. I need to change this. Okay, that's fine. 14.9 is fine. Does not need to be perfect. 14.9. All right, so now we change that to 220 like I was before. I don't think it's a big deal. It will work fine. I don't think it's a big deal. All right, let me see what else I need to explain you guys. So what else? Do not forget the ground. This ground will feed this circuit right here. This circuit, I learned this circuit from the Mr. Ostripper. So basically, this is like a separate ground for the input ground. You can see this is the positive right here, in positive, and the signal ground. So that's another way to have a lower distortion having this circuit here. And this that's why it says optional ground circuit, to separate the ground. So to have the amplifier not having the hum or noise. And one more, lastly, one more thing. Now I remember now. One last thing that I need to tell you. The reason I place these pads over here is in case you want to have the potentiometer. Did I say that right? The pot, the trimmer pad, pot. Sorry about that. It's separate. You want to have it on the case, so that way you can adjust the bias, having that close to you, depending on where you want to place the bias part. So that's why I have those pads there. If you want to use a larger, but I really recommend it to use the correct one, the correct trim pad, so you can adjust the bias correctly. It's 2K, so you will have flexibility to adjust the bias. That's why this one is 2K, so you will have plenty of room to adjust the way you want it. So it's supposed to be a 500 ohms, but 2K is fine, 1K, 1.5K also. So you will have more accurate adjustment. That's the correct word, more accurate adjustment. And I'm going to show you how the PCB is going to look like after you put it together. I'm going to do it right now. I'm going to copy this board. So I'm going to show you an illustration of how it's going to look like with all the power transistors. So a visual reference of how it's going to look like. So right now, making this video in English today because I know there are many people that this one here is the bias transistor. As you can see, don't forget emitter, collector, base. Emitter, collector, base. So right now we're going to place it here, and I need the other transistor so I can show you a visual reference so you will know. Give me a second, guys. I need to find the other transistor. Okay, this one here is the driver transistor. There you go. I'm going to place it here. They're going to be attached to the heatsink. Do not forget that. Also insulated. Do not forget to insulate. It's really important. Don't forget to insulate. Okay, so this one will be placed here. Let me see the distance that we have here from the collector to collector. Okay, we have 22.5 millimeters. 22. Okay, so I'm going to do it this way. 20. We got 6. 20. Did I say 20? 20.5, right? Did I say that right? No, that's not the correct value. Okay, no, don't worry about it, guys. I just need to make sure I have correct. Okay, let me see. Oh, 22.5. Sorry about that. It's supposed to be 22.5. Don't worry about it. I'm going to do it right now. 22.5. We have 6 transistors. There you go. So it's going to look like this. So I'm going to place the other like this, and this is the one of the driver transistor. There you go, driver transistor. There you go. Remember, this area right here is the positive area of the transistor. So these are NPN. These are all are NPN transistor. Do not forget that NPN transistor, and the bottom one is a PNP. Do not forget that. Just like on the schematic right now, you can see. Let me see. Did I have that correctly? Q13. Q13 is NPN. Q13. As you can see, this one is NPN, and the bottom one Q11 is PNP. Do not forget that. Q. Okay, let me see. Did I have that correctly? Let me see. I think this it says Q11, and this one here says Q12. I don't mind about that. I can fix that probably. So this says Q12. Maybe I change it on the schematic, but it's fine. Just need to the only thing you need to know that this one here is PNP, and the output power transistor they are PNP. And one last thing that I need to tell you guys, that the reason I have these diodes here, let me split this group right here. The reason I have these diodes, 2 diodes, gotta split this so I can explain you better. Gotta split this. There you go. These 2 diodes are part of the circuit of the original schematic. Let me see if I can find the original schematic. The AX-14. Let me see if I can find it. Oh, they are new designs from Mr. Miles. So, but I don't have the time to do it. So I really want to try that. Right now, let me see. AX-14. I need to have the schematic. Let me see if I can find the actual schematic. No, that's not. That's not what it is. Okay, that's the older. It basically, to tell you now that you see these images, it's based this AX-14 Golosa is from this design. So you will have a larger version of this design, and it sounds pretty good. I mean, I cannot complain about the sound of this amplifier. It's pretty good. Let me show you. I need to find the. Let me see. Let's see if I can find AX-14 schematic. I need to find that. Let's see. I need to find the original schematic. Let me see. Okay, this is the original schematic, as you can see here. As you can see, this is negative feedback, the negative feedback resistor. Okay, these values on this schematic, they are wrong, because RA is supposed to be 560 and R2 is 22K. So don't mind about that. We already figured out that a long time ago, so don't worry about that. So these are the actual. Oh, it's correct. Oh, it's correct. As you can see, this is the driver PNP. Sorry about that. Transistor is Q11. So on the layout is correct. So don't mind about that. So it's correct. It's Q11. So it's fine. It should be no problem at all. So as you can see, these diodes are the ones that are present on the original schematic. Now I'm going to explain you why I have these other two extra diodes. The purpose of those diodes is to avoid any further damage in case you connect the amplifier wrongly. One example, you forgot to place the positive. Always use a positive. Always use a red wire for the positive, and the negative wire, you will use a yellow wire. Yellow wire will represent the negative voltage of the supply voltage, and yellow, and black to as ground or tierra or terra, whatever you call it. So one example, I'm going to show you a small simulation that what will happen if I misplace the wire. As you can see, this is the correct connection of the amplifier right now. What I'm going to do right now is going to remove this wire from here. I'm going to remove the meter. So I'm going to place, let me see, this is on ground. Okay, this is the diode that will protect the amplifier. As you can see, we had the cathode is on the positive and the anode is on the ground. So if I misplace the positive to the bottom. One example, this is the positive of supply voltage, the positive area of the symmetrical power supply. So right now I'm going to disconnect the negative from the bottom. I'm going to connect the negative from the supply voltage. I will place the negative to the positive area of the amplifier in purpose, just to show you the purpose of those diodes. So that's a good thing in case someone connected wrongly, like I say, and it will protect the amplifier. Right now I need to place a junction connection, so I can make a connection for the positive to the negative. So I will show you. It will blow the fuses right away. Okay, right now I'm going to make those connections, so just to show you a simulation of a wrong connection. So I'm going to activate a simulation. I don't know for how long they're gonna last. Let me see. You can see it blows the fuses. It took a longer time because these are 15 amp fuses, but if you are using a lower value, one example 10 amp, they will blow a lot faster. So that's the reason I place those diodes, diode 6 and diode, that's the other one, and diode 7. So those are the purpose of those diodes. Actually, I did not how you say, I did not how you say, identify those. Sorry about that. I identify those diodes. It's okay. It's okay. The most important thing that they are present on the circuit. So these diodes are the one that will protect the amplifier in case you have a wrong connection. I don't think it's gonna happen with you. You are been doing this for a long time, but it happens because I think Mr. O'Stripper or someone else from DIY.com, he mentioned that he wrongly connect wires and he destroyed one really expensive design of audio amplifier. He was so pissed off. He was so mad about it. So I kept that in mind. Damn, I gotta do that with my design, so in case something happens. So, right. So do not forget also. Lastly, do not forget to place the ground. The speaker ground will be connected here or anywhere. Any of these areas you can connect the speaker ground, and this connection is from the power supply, of course. And one of these you will need to connect. One piece of wire will be connected. I'm going to show you right now. You will connect one piece of wire. This is an example. This is the ground wire. You will be connected here with the fasten connector. So to make sure you have that ground there, don't forget that wire. That wire is really important. All right, guys, that's it. Making this a longer video to explain you about the Golosa. You will have the choice of 4 pairs, 3 pairs. We had the 2-pair version. I don't think 1 pair make no sense to make 1 pair version because I have the older version of the AX-14. So we got 3 pairs, 4 pairs, 6 pairs. So you will have the choice. It's yours. So you can make a nice amplifier. I know it sounds really good. I imagine that it sounds pretty good, even better with more pairs because I'm using the one that have only 1 pair, just like the image. Like this photo, this is the one that I have, and it sounds pretty good. I like the sound of this amplifier. Alright guys, that's it. Making a long video. I hope you guys have a good day. Make sure you have all components correctly installed into your circuit, and I hope everything goes fine in your first test. Like I said, do not forget the light bulb. Really important. Alright guys, have a good day. Subscribe to my channel, like this video, and have a good day. Oh yeah.